Problem F12 38. At the instant theta equals 45, the athlete is running at a constant speed of 2 meters per second. Determine the angular velocity at which the camera must turn in order to follow the motion. So, we start out with the equation then of R. And R is equal to 30 CSC theta. Now, we want to take the derivative of this, so let's change this into 30 over the sine of theta for R. So taking the time derivative of both sides, R dot equals bottom d top, so the bottom is sine theta and the top is the derivative of 30, which is 0. So sine theta times 0 minus top d bottom. So 30 times the derivative of the bottom, which is cosine of theta. We need to apply the chain rule, and so we need a theta dot, the derivative of theta itself, over the bottom squared, sine squared of theta. We can simplify that. This goes away. Negative 30 cosine theta, theta dot, over the sine squared of theta. Okay. Now VR is equal to R dot. And V theta is equal to R theta dot. So, we know what R is, or the magnitude of V and R, or V theta R, because that is the speed of 2. So putting those into the square root of the squares, we can solve for theta dot, which is what they're asking for, the angular velocity, which the camera must turn, is theta dot. So first, let's find the values for R dot, R, and theta dot when theta equals 45. Right there. Okay. So R is equal to 30 CSC of 45. Better yet to do 30 divided by sine of 45. And we got to do R dot, which is equal to negative 30 cosine 45 theta dot over sine squared of 45. And that's it. So R is equal to 42.4, and this is equal to negative 42.4 theta dot. So V is equal to square root of R dot squared plus R theta dot squared. So V, which is 2, is equal to square root of negative 42.4 theta dot squared plus 42.4 theta dot squared. And we solve that, and theta dot is equal to 0.0333 radians per second.